Gentlemen, please welcome Linda Maepa.
Hi, good afternoon. I am so thrilled to see people here interested in hearing about energy cybersecurity. It's a topic that has been gaining more and more interest over the past several years, and I'm thrilled to see that the Bill audience is included in that. Let's see if I can, there we go. So let me introduce myself a little bit. My name is Linda Maepa. I am a scientist, but I wear many hats. My background is actually in geobiology, which may seem like an odd place for a battery entrepreneur to end up, or to start with, but in fact, it makes all the sense in the world because geobiology and actually a lot of the geosciences are system sciences. And what's happening in energy, just like in aerospace and in computer programming, is that you're working with systems, and often, if you look at the Earth, systems of systems. And so that's how I became an engineer. My former lab partner from tech and I, we had lost connections, got back in touch, and he had been instrumental in starting up a small company now known as Tesla Motors. And he was doing the battery systems for that company. And he said, these things are really expensive. What are we going to do? So he started an R&D project, which he brought me on board of, which eventually became our company, ElectronVault. And my work in energy storage has really been very interesting. Because energy storage, even today, is largely demonstration projects. But what's most interesting is that there are a lot of places where energy storage is viable commercially today. Not a lot of people are looking in these areas, and because of that, there are problems and opportunities that are not being properly addressed. I'll be talking about the cybersecurity problem in energy and technology development today, which is one of the huge problems. But also, because of some of the gaps and some of the areas that I see that are opportunities today for energy storage, I'm starting to put on an investor hat. So we're at a crossroads today. One of the early titles, which I decided not to go to for copyright reasons, for this talk was Panem versus the Federation. Let's talk about what a scarcity future looks like and what's an abundant future look like. And it all comes down to how are we going to go forward with our development of energy technologies. So what does the future bring if it's abundant? What does it look like? To me, a child of the 70s, it looks like the Federation. It looks like live long and prosper. We're going to have an environment where we have energy to power autonomous vehicles. We're going to have energy to power infinite manufacturing that is mass customized at the place of use. We're going to have energy that is on top of a mountain in the middle of the desert. It doesn't have to be in a centralized location. Of course, a lot of our energy infrastructure today is centralized. So how are we going to be able to move from our centralized to a decentralized future where, to be quite honest, I think even a centralized system has applicability. In any case, we're going to have to move energy around, either between people, between machines, and from central locations to those that are less centralized. The problem is that today we have one grid. And in general, that grid has been well understood, managed with certain givens associated with it in terms of what kind of physical hardware is used. That hardware has been around for a long time. Specifically in the United States, we're looking at an enormous grid modernization project. Firstly, it's typically discussed as smart grid because all the new entrants to the energy field, of course, want to have their new smart products incorporated into the new grid. But also, the grid's been analog for a really long time. So adding these new resources that are often digital, that are connected to the open internet, that can provide a certain degree of problems. So let's break down very quickly what is the grid. The grid is three systems. It's the generation, it's the transmission of the energy generated in the generation system, and it's the distribution. How does it get to our homes and businesses? And there are technologies that enable and improve each of those areas, but you have to be careful. Because I decided not to go with the Hunger Games, instead I went with Dune. He who can destroy a thing controls it. In the spot market for California's energy market, you can see $100 per kilowatt hour price for energy on a daily basis. Compare that to what you're paying for energy. In the same California market, you can see $540 per kilowatt hour being paid for on about a weekly basis. This is not sustainable. There are a number of reasons for that. I'm not going to go into them now because of time. But these are some of the challenges of market design and market risks that can be exploited or can be fixed depending on what type of hardware you put onto the grid. You know, in a nightmare scenario, you could have, for instance, an energy storage system that's connected to the grid, and basically they're paying a low price, having it go through the energy storage system, and on the other end, in real time, it's $540 per kilowatt hour. And they paid, what, 10 cents per kilowatt hour? So market manipulation has huge impacts, potentially, for the grid and creates artificial scarcity. Then there's terrorism. In the Bay Area, there is a substation that has been attacked not once but twice, and now has a great deal of equipment for monitoring potential intrusions. We've had fiber lines cut, and that's not confined only to California. We've had cyber attacks on the eastern seaboard from foreign actors. And so terrorism and the ability, when you have new technology on the electric grid that can control what's happening or deny access to services, has enormous implications at the national level, but also, you know, for mom and pop at home. So how can we create a better future? How can we get to that abundant future? By developing better technologies. We don't need Bill Gates to tell us that we need an energy miracle. We do. We understand that. We need people who are thinking about how to build new technologies or how to develop new energy systems that work with what we have today, but are also secure, solve new problems, provide energy access, provide mobility. And the way to do that is through innovation. But we need rapid innovation. Because one of the things I have not mentioned is low carbon. In the United States, nobody wants to talk about low carbon. Luckily, I operate in the US and outside of it. And in terms of treaties and other commitments that have been made on an international basis, in order to have a viable low carbon future, you really need to come up with economically viable alternatives. You cannot have technologies languishing only at the development stage, deployed only in pilots and never reaching commercial viability. So on the tech development side, it's really about design. It's really about awareness and designing for security. And so if you're able to design your systems, whether they be on an analog basis, whether they're mechanical, whether they're digital but don't offer command and control capabilities, whether, in terms of operational security, that you're able to shield information about what's happening on site from those who don't need that information. Those are the sorts of things that we need to be thinking about as technology developers. And in terms of cybersecurity, what's fascinated me is there is a dearth of cybersecurity expertise in the tech industry, and even more so in energy. And the thing is, I think in some ways, I've gotten a lot of calls over the past 6 months from folks I've known for a long time, folks I've lost touch with, who are asking about getting into energy. And I ask them, well, what is it you're doing now? And they're typically in IT. And I say to them, look, you have certain strengths. Energy touches everything, from data centers, there's a guy in health IT, to community health, and how does that impact what our health infrastructure looks like? Why don't you look at what's happening there and bring your expertise into the energy industry, especially when you're coming from an IT background, getting into cyber, that's easy. There are a lot of resources, and I'll share a link at the end that has some of the resources that people can get in touch with in order to learn more about cybersecurity. And so desperately urging anyone who may be in tech or traditional IT to think about, if you're burned out, come to energy, because we need you. We have a huge turnover happening right now between an older workforce and a younger workforce, both in the operations, but also, because folks do not have information about cybersecurity. So as I'm saying, I'm asking folks to be the change that we need in order to have a more abundant future, rather than thoughtlessly running into a future where other people are controlling our energy and our ability to do whatever it is that we wish to do. So get out there, network, come talk to me, connect with me on LinkedIn, on Twitter, although I don't talk much there. Connect with me, and I'll connect you with the rest of the energy industry. I'd love to hear what you're doing. Further, there's places where you can learn, as I mentioned. And it is so exciting to be in energy right now because it is undergoing a huge transformation. And then volunteer yourself, right? Wherever you are, if there's something you see to get your sea legs in energy, nominate yourself to be the one to carry that standard in your company or in your own life, and learn about what it is that you can do to build up your skills. And then there will be those who can create opportunities, people in companies, people with money, people with a need to have something done, right? Bring yourself forward, if that's you, so that we can work together on creating an abundant energy future. Thank you.
Thank you, Linda Maepa.